Welcome to our online lecture. Our topic for today is all about Introduction to Semiconductors. Ano-ano nga ba yung matututunan natin sa topic na ito? First, review of the atomic theory. Second, review of crystal structure. And third, the semiconductor theory. Simulan natin sa quantum mechanics. We all know that all matter is composed of atoms. At lahat ng atoms ay may electrons, protons, and neutrons. One of the contributors sa atomic theory ay si Niels Bohr. Niels Bohr was a Danish physicist. He proposed that electrons in atom circle the nucleus in different orbits like planets in the solar system. This model was called Bohr model, and it is often referred to as planetary model. What is Bohr model? Bohr model states that atoms are the smallest particle of an element. Atoms have planetary type of structure that consists of a central nucleus surrounded by an orbiting electrons. Sa central nucleus, dyan mo makikita yung protons and neutrons. At ang electrons naman ay nasa mga shells. Let's have some discussion about the relationship of electrons and its shell. Electrons near the nucleus have less energy than those in more distant orbits. Why? This is because the force of attraction between proton in the nucleus and electrons decreases with increasing distance from the nucleus. Kaya habang palayo ng palayo, ang mga electrons sa shell ay nagiging mas energized. Kaya sa last shell or sa valence shell, nandyan ang highest energy. In an atom, the orbits are grouped into energy levels, known as shells. What are the maximum number of electrons in every shell of an atom? Okay, let's go to the next slide. The formula to compute for the maximum number of electrons in each shell is number of electrons is equal to 2n squared, where n represents the shell number. In shell 1, the maximum electron is 2. In shell number 2, the maximum number of electrons is 8. And in shell number 3, the maximum number of electrons is 18. Be reminded that the remaining electrons will become the valence electrons. For example, the silicon atom na nakikita nyo yung figure at the left side. Atomic number ng silicon is 14. At ang atomic number is equal to the number of protons and number of electrons. Silicon has 14 electrons. Kaya in shell number 1, it has 2 electrons. In shell number 2, it has 8 electrons. And in shell number 3, it has 4 electrons. This is the remaining electrons. These are the valence electrons. Valence electron is present on the outermost shell, called valence shell. Electrons in the last shell has the highest energy exist. Okay, tapos na tayo sa review ng atomic theory. Let's have some review about ionization. Ionization is losing or gaining electrons. To produce a positive ion, we need to give up or lose electrons. Just an additional tip. Kapag mas marami ang protons, yun ay positive ion. At kapag mas marami naman ang electrons, yun ay negative ion. 'Di ba sa isang atom, equal lagi si number of protons at number of electrons. Bakit naging positive ion ito? Kasi nag-give up siya ng electrons. Ibig sabihin, nabawasan yung electron niya. At yung escape valence electron na ginive up niya ay tinatawag ding valence electron. Kaya siya naging positive ion kasi mas marami na yung number of protons niya kaysa sa number of electrons niya. And sa negative ion naman, kaya siya naging negative kasi nag-accept siya ng electrons, meaning nadagdagan yung electrons niya. Reviewin naman natin yung types of material according sa conductivity and valence electrons. First type of material are the conductors. We all know that conductors easily conduct current. At ang valence electron ng mga conductors ay from 1 to 3 at yung mga valence electrons na yan ay mga free electrons. Silver is the number 1 of the best conductor pero expensive. Copper is efficient conductor and cheaper. Gold, yan ang conductor na makikita natin sa loob ng mga IC wiring. Aluminum, yan naman yung mga nakikita natin sa IC pins, and aluminum are compatible with solder or what we call soldering lead. Insulator. Insulator does not conduct electrical current. Valence electron ng insulator ay from 5 to 8, meaning walang free electrons. Kaya hindi siya conductive. Examples of insulators are plastic, rubber, glass, mica, and quartz. Semiconductor. Semiconductors are neither conductor nor good insulator. Semiconductor are in pure state, meaning intrinsic, because they exactly have 4 valence electron. Pwede silang mag-bond with the same semiconductor with 4 valence electrons forming a crystal. Later on, we'll discuss about this crystal structure ng semiconductor. Some example of single semiconductors are antimony, arsenic, boron, phosphorus, silicon, and germanium. At ang mga common sa mga ito ay silicon and germanium. Some example naman ng mga compound semiconductor are gallium arsenide, silicon carbide, and indium phosphide. And each type of material also differ in energy band gap. Energy band gap. Valence shell represents a band of energy. Ang band of energy ng valence shell ay valence band, forbidden band, and conduction band. Valence band, this is the region where the valence electrons are occupying. Forbidden band, this is the region where no electrons exist. And conduction band, this is the region where free electrons jumps and have higher energy level. When an electron acquires enough additional energy, it can leave the valence band, become free electron, and jumps in what is known conduction band. And each materials have energy gap. And ang unit nito ay electron volts or EV. Energy gap is present between the valence band and conduction band. Insulator have 5 electron volts, meaning wide yung gap niya for an electrons to conduct current. Maghihirapan ang electron mag-jump from valence to conduction band dahil malaki yung energy gap. Semiconductor have 1 electron volt, meaning narrow yung gap. It can conduct current if and only if impurities will be added to add more electrons or holes. Adding impurities will enable electrons to jump from valence band to conduction band. And sa conductor have 0 electron volts. That is why electrons can easily jump and conduct electric current. The wider the energy gap, the harder the material produce free electron. Let's discuss semiconductor theory. Silicon and germanium are common single semiconductors. These are used in diodes, transistors, integrated circuits, and other semiconductor devices. Both silicon and germanium have 4 valence electrons. In addition, gallium arsenide are also compound semiconductor at common itong semiconductor na ito. Let's compare the three semiconductors. Germanium has an energy gap of 0.67 electron volts, and these are most sensitive to temperature. This sensitivity makes germanium unstable and results in excessive reverse current. That is why hindi ito masyadong gamitin. That is why silicon is most widely used in semiconductor material. Silicon has 1 electron volts in its energy gap. Silicon are the most abundant and most efficient semiconductor material. While gallium arsenide has an energy gap of 1.43 electron volts. And these are the fastest semiconductor material. Now let's go to the covalent bond of semiconductor. Covalent bonds is sharing of valence electrons forming a crystal lattice. For example, silicon has 4 valence electrons and it requires another 4 valence electron to complete its shell. Kaya kapag nagsama-sama ang mga silicon with 4 valence electron, it forms a crystal lattice. Using your photographical mind, kapag nagsama-sama ang mga silicon, they can form a cubic crystal. They create a covalent bond of semiconductors. Ang tawag sa type of semiconductor is intrinsic semiconductor. Intrinsic semiconductors have no impurities. They are tetravalent atoms and they are in pure state. Common sa intrinsic semiconductors ay nagfo-form ng crystal. With these properties, they are poor conductors because there is no free electron. Semiconductors are generally poor conductors. Para ma-increase drastically yung conductivity, we need to add impurities. Ang mga impurities na i-add natin, either pentavalent or trivalent atoms. At ang process na ito, ng pag-a-add ng impurities ay doping. Doping increases the current carriers. And what are these current carriers? Either electrons or holes. Electrons are negatively charged particles, while holes are lack of electrons at a position. Okay, let's discuss this well. There are two types of extrinsic semiconductors, the N-type and the P-type semiconductor. The N-type semiconductor, to create an N-type, we need to add pentavalent impurities. Pentavalent impurities can be antimony, phosphorus, arsenic, or bismuth. From our previous slides, diniscuss doon na 4 na valence electron ang need ng semiconductor to complete its shell. Pero dahil pentavalent ang dinagdag natin, may excess na 1 valence electron. Ito ang magiging free electrons. Pentavalent atoms give up electrons, often called as donor atoms. Adding more pentavalent atoms create more free electrons. Kaya ang majority carrier ay free electrons. At minority carrier ay holes. These few holes are created when electron-hole pairs are thermally generated. Ganito natin nilalagay sa diagram ang N-type. Kung makikita nyo sa figure at the right side, mas marami yung free electrons which are the yellow one kaysa doon sa holes which are the white ones. Okay, ganito ang diagram ng N-type. Okay, let's go to the P-type semiconductor. To produce P-type, we need to add trivalent impurities such as boron, indium, or gallium. At dahil trivalent impurities, lack of electron at a position ang mapoproduce which are called holes. Trivalent can take an electron, often referred to as acceptor atom. Kaya adding more trivalent atoms, it produce more holes. Ang majority carrier ay holes at ang minority carrier ay electrons. Ganito ang diagram ng P-type. Kung mapapansin nyo, yung white, yan ang mga holes. Mas marami ngayon yung mga holes dahil nagdagdag ka ng mga trivalent. At meron pa ding napoproduce na free electrons. Hoping na marami kayong natutunan sa topic natin ngayon. And see you next class. And thank you for watching.